All right, so we're going to look real quick at gear ratios. So I've got just a sheet of paper, and the thing to remember about gear ratios is that when you have two gears that are meshed together in some way, when we talk about gear ratios, what we really care is the ratio between the drive gear, so the gear that has the power, whether it's a motor or a crank handle or something like that, and the driven gear. And so the driven gear is just the output. Okay. So the drive gear has the motor. It's also known as the input gear. And then the driven gear is the one on the end, the one that's connected to the wheel or whatever you're doing, but it's the output. And when we talk about this, these ratios are always determined by the ratio of the output over the input. So it's a mathematical expression. Now, if they're real gears, then generally what we're talking about is the number of teeth in the output divided by the number of teeth on the input. It doesn't have to be this way. You can also compare things based on, for example, maybe the circumference of the gear itself, if you'd like to. Sometimes if you have two rubber wheels pushing up against each other, functioning like a gear train, you'll do a circumference because it doesn't have teeth. But that's something to think about. So I have a couple of example pieces right here. And so let's look at this one. So these large gears are 60 tooth gears. That means there are 60 of these teeth all the way around. And this gear, the smaller one, this is a 32 tooth gear. So let's take, for example, say that this one is our drive gear. So this is the one that we're adding power to, and that'll just be me turning it. So our output is this one, the smaller 32 tooth gear model, or excuse me, 36 tooth gear, not 32. So when we talk about this, teeth of the output versus teeth of the input, that's 36 over 60. So 36 over 60. Now, obviously, that number screams to be reduced. It's just a fraction. So these are both divisible by 6. So that can become 6 over 10. And you'll notice immediately, well, those can also be reduced. So 6 and 10 can both be divided by 2. So that would become 3 to 5. So this gear ratio is 3 to 5. So think for a moment, if this gear ratio is 3 to 5, how many times will this turn to make this one turn? Which one basically turns 3 times to make the other one turn 5? Think about that for a second, and then let's find out. So I'm going to start turning this one. There's 1 time. And remember, what we're looking for is for when these orange pins line back up. 2 times. 3 times. So this gear, our drive gear, turned 3 times, and our output gear turned 5 times. So even though in our equation we have the number of teeth on the output to the number of teeth on the input, what it really comes down to is that this is the revolutions of the drive gear over the revolutions of the output gear. So it's 3 to 5, or 3 revolutions of the drive gear to 5 revolutions. And remember, a revolution is just a gear going around 1 time of the driven. So this math holds up every time, just based on the number of teeth. So flipping this around, I've got another different gear set. Now this one's much different. This one we have a 60 tooth gear, again the same giant gear, and we have a teeny tiny little 12 tooth gear. It's real hard to see. I've added a little piece of copper tape to match up with my pink pen. So again, let's do the math real quick. So which one are we going to say is our drive gear? I'm going to say that my 12 tooth gear is my drive. So if I were to draw it, we'd have a small drive gear and a big driven. So again, we have an input and an output. Okay. So our drive gear has 12 teeth. Our driven gear has 60. So our output over our input is going to be 60 divided by 12. Now, reduce that fraction. They're both divisible by 12, so we get 5 over 1. So based on what we learned the first time around, this is saying that 5 revolutions of the drive gear, so the small 12 tooth, will result in 1 revolution of the driven gear. So let's find out if that's true. So I'm going to turn this gear real carefully. There's once around, twice, 3 times, 4 times, and 5 times. So that worked out correctly. We had 5 revolutions of the drive gear to 1 revolution of the driven gear. Now, the other thing to think about is torque versus speed, and the size of the gears matters. So again, taking this one into account, if our drive gear is the small gear right here, this 12-tooth gear, if we turn this on a motor that, let's say the motor turns 1 time every second, so it's turning 1 time every second, does this one go faster or slower than 1 time every second? Well, it must go slower. In fact, it takes 5 seconds for it to go around. So this is a torque gear ratio. It's slowing down the input speed, but it's providing more power or more torque. Now, if we switch it around and say that this is now our drive gear, so this is where the power is being input, 1 revolution of this will produce how many here? Well, if we go back to the math we just did, if it was 5 to 1 going this way, well, it must be 1 to 5 going the other way, meaning that 1 revolution of this gear will spin this 5 times. So we can test that. You can watch that copper tape flip around real fast. And yeah, it did 5 times versus 1 time. So again, this is a matter of not a torque ratio, but this is a speed ratio. Okay, basically saying that 1 revolution here. So again, if you go back to the whole concept of this revolves 1 time every 10 seconds, means that this one revolves 5 times every 10 seconds. So it's a speed ratio. That means that if you put the power here, your output is much faster for what you're doing. So you get a speed ratio. But this is just the ultra basics of calculating a gear ratio using basic gears just by the number of teeth to determine if it's a speed or torque ratio. So remember, 5 over 1 or a big number over a small number, that's going to be your torque ratio. If you work it out the other way, so that, for example, when we flipped this around and we had 12 as our output and 60 as our input, well, that becomes 1 to 5. So small number on the top, big number on the bottom, that's a speed ratio. So these are the basics of calculating a gear ratio based on the number of teeth on a gear.